Welcome to today's webinar titled Introduction to GlusterFS. My name is Heather Wellington, and I will be your host for today's webinar. GlusterFS is an open-source, scale-out file system that has been downloaded hundreds of thousands of times by tens of thousands of organizations worldwide. It is being used for a wide variety of solutions, including archive, file serving, platform as a service, disaster recovery, HPC, and more. Gluster provides a better way to do storage by enabling organizations with greater flexibility, unlimited scalability, and superior storage economics. During this webinar, we will take a look at the design goals for GlusterFS architecture, including major features and common deployment scenarios. And now, let me introduce our speaker, Tom Trainer. Prior to joining Gluster, Tom was an independent storage analyst. Tom also held positions such as Managing Senior Partner at Evaluator Group, an IT analyst firm, and has also worked as Director of Marketing at EMC, HDS, and NAS Pioneer Auspex during his career in IT. And now I'd like to turn it over to Tom to begin the presentation.
Thanks, Heather. Appreciate that. And that's a nice introduction of me by you. I appreciate those kind words. Also, interesting poll results in that 27% of you are currently using Gluster in production. So you'll know of some of the topics of which we speak today, and some of them will be new for you. And then for others of you who are just researching or currently testing Gluster, you'll get to know some new interesting attributes of the Gluster file system. So I will tell you a little bit about the history of the company. We started as a high-performance computing kind of environment, and how we got there was through our founders, A.B. Periyasamy and Hitesh Chalani, working at Lawrence Livermore Laboratory in California and trying to develop the world's fastest supercomputer. And in fact, they did develop one of the world's fastest supercomputers, and in the process found that the bottlenecks that needed to be fixed in developing a supercomputer came down to networks and processors and file systems and storage. And they fixed each one, and they finally got down to the disk and the storage, and they figured that there was really no way to get around the fact that there were metadata servers and distributed metadata characteristics inside of a disk file system. And so they sat down and said, you know, what we really have here is a mathematical problem and not a physical problem, and we can solve this problem through the use of algorithms. And they did. And in fact, in doing so, they later left Lawrence Livermore Lab and the company they were working for there and started their own company, now known as Gluster. And as a result of all of that, we have developed, as a company, some significantly innovative software, and certainly an award-winning approach to designing, developing, and distributing a software-only based storage scale-out file system. So what is a Gluster file system? Well, the Gluster file system is a scale-out file system for object and network attached storage, or otherwise known as NAS. GlusterFS provides flexibility to deploy in any environment, whether it's a data center or a public cloud. Multiple public clouds are supported today, including Amazon and GoGrid. We support high availability with synchronous and asynchronous replication. We now support the unified files and objects approach to the file system. So we'll talk a little bit about that in further detail and show you some examples of what that looks like. We scale to petabytes and beyond. And so we have traditionally over the past couple of years talked about the petabyte file system, but we're beyond that now. And customers of Gluster today scale well beyond a petabyte and into double digits and triple digit petabyte installations worldwide. And our performance is linearly scalable. So GlusterFS is designed to deliver linear performance and scaling out the number of nodes in a file system without losing performance characteristics. And then all of this wrapped up with superior economics through the use of commodity hardware. Today, from an innovation perspective, we eliminate metadata scalability, and the capability to grow the file system, to grow the number of nodes within the file system, and to increase capacity and scalability for performance. And in doing that, we scale linearly. Linearly means to be able to increase performance and increase capacity and provide linearity within the file system. So file systems are great, but to scale them from a capacity perspective and lose performance is a thing of the past. And that's traditionally associated with the metadata server file systems or distributed metadata file systems. So in doing that, we make the file system much more simple to deploy, simple to manage, and simple for ongoing expansion of the capacity and performance. So some of the differentiators with GlusterFS is that we run in user space. So we're not tied to the kernel, and that means that if there are kernel patches and kernel updates, it has nothing to do with GlusterFS. So we don't get bogged down or tied down each time there's a kernel patch, or if in fact there needs to be a kernel patch. It does not affect the file system. So we run in user space, makes life a lot easier for you as a user to manage your storage file system. We're software only, so software only means that you now have portability to deploy NAS and object storage in the data center on bare metal or in virtual machine environments or in the public cloud in Amazon Web Services or now even GoGrid's enterprise cloud environment. We're open source, which means you can download GlusterFS from www.gluster.org and get GlusterFS and try it as a open source download. You can also do that from our .com website as well. We offer free trials for all of the various environments that we deploy in today. So we're modular, we're stackable, and that means that you can use certain bits and pieces of GlusterFS and choose not to deploy certain modules, or you can actually roll out and go ahead and deploy. Like replication, you can choose to use N-way replication or synchronous replication, or choose not to use N-way replication. Your choice. And we store the data in native formats, which means ext3 or ext4, and what that means is you're not locked into GlusterFS. So not only are you not locked into the hardware, you're not locked into the file system either. So if you decide to remove Gluster, you have immediate accessibility to all of the files which you've written through Gluster. And that's a uniqueness with Gluster. Every other file system has the unfortunate capability of, in many cases, recording in a proprietary fashion, which means you have to go through a migration in order to remove, say, Isilon or NetApp. You have to migrate those files out of the file system to a new installation. So today we support unified files and objects, which means you can store files within Gluster and then also see them and export them as objects. Or you can store objects within Gluster and see them and access them as files from an NFS and CIFS perspective. And then, of course, today we also support, recently announced this week, the virtual motion of virtual containers or virtual machines in a KVM or Xen environment. So this is analogous to VMware, where vMotion is supported between ESX physical servers. Now today, users of OpenStack, Open Cloud Initiative components can actually now support virtual motion of their virtual machines. So when we say we run in user space, what we mean is we're not tied to the kernel. There are no reassembly requirements with Gluster when there are kernel issues and changes. And you have independence. Independence to move the storage and move the servers and move the file system to any space or any place that you desire. So being software only means that we're hardware agnostic. You can choose your storage system to install Gluster upon. And in fact, you can choose the servers that control those storage systems as well. You see with Gluster, the servers and the storage are essentially building out a NAS or an object storage environment. And you get to pick the server node or the NAS node or NAS head, if you're familiar with NAS PMC, very similar concept. You get to choose your best of breed for your environment, or your lowest cost, if that's the most important element, lowest cost storage and lowest cost server / NAS node or object controller. And then you don't have a lock-in, right? So in this case, where you have the choice of storage, you're not locked in. So if you have a volume purchase agreement with Dell, you can use Dell servers, Dell storage, and GlusterFS. Likewise, or conversely with HP, you can do the same thing. Now, as we mentioned earlier, we're an open source company, and we started as an open source company from the very beginning as an open source project, and we still continue that today. Gluster.org is our community site. You can download GlusterFS. Even the latest version of GlusterFS 3.3, which we'll talk about today, can be downloaded and deployed and tested. Now, today we have over 200,000 downloads, and as of the end of this month, we'll be averaging right around 15,000 per month continual downloads. With 500 registered deployments, which are typically production deployments through the open source download and use of the open source project software, and an active community, a very active community. We have our community manager, John Mark Walker, who's been on board now for a couple of months, actively developing and supporting the community. We've had local Bay Area community meetings, a Birds of a Feather meeting recently at OSCON in Portland earlier this week on Monday, and we will continue to have local chapter meetings of the Gluster community and Gluster user groups worldwide. So look forward to, look at the .org site and keep up on the .org site blog and also the .com site blog, where you can find out more information about upcoming user meetings held by Gluster, or cloud camps or Birds of a Feather sessions in your local area. So what does this no metadata server concept really mean? Well, it means an algorithmic approach, which is developing unique hashtags for each file stored, each and every file stored. And these tags are stored within the file system. And what happens as a result of all of this is that the files are read back and delivered to the application or a web cache or a user exponentially faster than any other file system available today in the marketplace. So here's an example of a traditional metadata server file system, where the actual metadata server may be contained within the file system, or it may in fact be a separate physical server acting as a log or a journal to keep track of where and certain attributes about files that are stored within a file system. So we can see that this is a nice approach, and that for small numbers of files, or maybe small numbers of large files in a file system, this approach works well. But it can't scale, because the metadata file server continues to grow and grow and grow, and the lookup time within the files, that metadata file server or index or journal, tends to grow exponentially longer as the number of files increase. And so another approach was tried to eliminate some of the performance bottlenecks, and it worked. But the problem here lies is that the metadata is still there, and the metadata has to be searched through to find the file that an application or a user is looking for. And that's important, and you've got to keep that in mind whenever you're looking at a file system for storage or any other kind of environment where you're going to write something. Even databases have the same kind of common problem, where you write information and you keep a log of where you wrote it. And it's very important to do that. That's basic computer science, so that you can go back and find what you're looking for if there's ever a problem, or as a general process. So what we did is we took an innovative approach and said, let's get rid of the metadata server and find a way mathematically to store these files and assign attributes to somewhere within the file system that enables us to find a file very quickly. And so what we do, and this is an example here where I say innovative elastic approach, This is not exactly how GlusterFS does it, because if we were actually to show you exactly how the hashing algorithm creates the hashtag, it would take us probably another webinar to do it. And it's not difficult, it's not complex, but to explain it to you is to explain algorithmic control, which takes a little time, because you want to level set that for everybody to understand. So here's an example of writing a file alphabetically, right, throughout a file system. So we just have a file, and as they come in, we store them alphabetically across disks. What we do is we create a hashtag, and that hashtag is stored throughout the file system. So there may be multiple copies of the hashtag, so that we can actually access the hashtag from anywhere within the file system, read it algorithmically, and then, execute on it algorithmically, and then read the file very quickly from the disk and transfer it to, say, a web cache or user or an application. So, simply put, what this means is that every file written within Gluster results with a hashtag associated with it. And these are small little hashtags that are stored within the file system, and when a read request comes back for the file, we run that hashtag through the algorithm, and we know exactly where the file is. So that's a lot faster than looking through a journal, especially when you have millions and billions of files in the file system. So you don't want to spend a lot of time looking through a journal. You want to get this hashtag, you want to find the file, and get it quickly. And we'll tell you about customers who have bet their business on this kind of approach in just a few minutes. So, interestingly enough, the way Gluster deploys is a unique global namespace methodology that's different from every other typical NAS vendor out there. And in this case, what we show is clients and applications accessing GlusterFS over TCP/IP and coming into the global namespace from anywhere and everywhere around the world. And how to look at this is, if we look at, say, Isilon, EMC's Isilon product, they have the capability of deploying global namespace, and it's really nice, and it's great, but it actually scales to about 144 nodes, and those nodes can't be global. They need to be in a data center. Well, if you compare that to Gluster, what we have is the ability to create a global namespace that can be in a data center and can also expand to the cloud and also include other data centers. So, and those data centers and cloud environments can be anywhere in the world. New York City, Tokyo, Chicago, San Francisco. You can have your NAS environment connected through a global namespace, one common mount point, NFS mount point, or one common drive from a CIFS perspective. And so that's very important to note that global namespace capability with Gluster is quite different, strategically different, especially for your business, when compared to, say, Isilon and even NetApp, who has a better, I think, global namespace methodology than Isilon, but still not the true geographically global capability that Gluster supports today. And so if we take that global namespace concept and apply it to practical implementation, we see today that private cloud users who deploy GlusterFS in a virtual machine environment, where we show on the left side the private cloud with GlusterFS deployed on a hypervisor and a server connected to storage, and on the right side, the public cloud, where amounts of elastic block storage, these two environments can be connected via a global namespace characteristic, a global namespace common mount point for a user or an application. Again, connected through the IP network to clients and applications. We also support replication, right? So two ways to look at this. You can replicate between the two environments for disaster recovery and business continuity. You can also share the files, right? Logically move the data, the files from the private cloud to the public cloud and back again. However you need to manage your information can be obtained with Gluster today. You can move files and folders from the private cloud to the public cloud. We have customers today who are migrating from the private cloud to the public cloud now that they can have NAS in the cloud a NAS file server configured within Amazon Web Services or within GoGrid environments, customers are moving their NAS files from the private cloud to the public cloud. And what value does that bring? That brings essentially the cloudification of their applications, right? They're able to move their applications now to the cloud because they can use NAS file servers in the cloud. And that gives you the capability of turning them on and using your NAS file servers in the cloud for as long as you need them, whether they're persistent or they can be temporary. You can have NAS file servers in the cloud that are turned on, filled up with information, operated upon, and then turned off, completely disappearing within hours. And so that changes the basic characteristic, the fundamental characteristic of computing and how much money is spent from a total cost of ownership perspective drastically, as you can see. So some of the deployment scenarios we have with GlusterFS today include media serving, large-scale file storage, file sharing, multi-tenancy, where many users are able to enjoy GlusterFS from a multi-tenant perspective, secure, and certainly sharing the file system. So we also support still high-performance computing environments, infrastructure as a service environments, as we talked about with Amazon Web Services and GoGrid, and others coming. There will be more IaaS players deploying GlusterFS throughout the year. Today we support disaster recovery with asynchronous replication, and of course business continuity with synchronous replication as well. So earlier, a week or so ago, on July 20th, we announced the beta release of GlusterFS 3.3. This is the newest version of GlusterFS, and it's really truly the first system for storing information that enables you to store and access data as an object and as a file. So we believe this is not just innovative, but the next generation of file and object storage. And so to show you what that means, we'll have an illustration for you, but it's also important to note that given that we're moving into the next generation, one would think we would do this very carefully and in a proprietary fashion, but that's not the case. We're still continuing with the open source version of GlusterFS, even at 3.3. So you can now, today, on the .org site, download GlusterFS 3.3 and start your own beta testing of unified file and object storage. Now, from a approach perspective, we'll take a look at a traditional approach that shows you how, from a hardware perspective, one vendor, in this case EMC, bundles together or builds together a file server, a NAS file server, an object storage environment, and then also supports fixed block architecture or direct attached through SAN through fiber channel connectivity or block connectivity. And so this is a good approach, and they call it the VNX, Victor Nancy Charlie VNX product, doing quite well for EMC from a hardware perspective, and EMC customers like it because it provides consolidation of storage environments. So it's much more cost effective. However, there's one little problem that still remains, and you can't share information across this hardware environment. You do share the storage, but you carve it up physically and logically between the three elements within VNX. Now, certainly a cost-effective alternative for EMC customers who need to consolidate and want to have the benefits of NAS, object, and fixed block architecture. But you still have to move the data off of this environment and process it somewhere else. Now, with Gluster, our approach is different. It's not a hardware approach. It's more of a software approach. We're a software-only company. And our approach to this is to blend it together and provide you a unified file and object solution from a software approach, a GlusterFS approach, that enables you now to store objects and access those objects from the file server side, from the NAS side, or NFS and CIFS access into the object. So today, you can store a group of files, a group of NAS files, and call that, and contain that rather, within an object, and export that object to S3. If your backup and archive environment is to take objects and back them up to S3, you can do that today. You can group files, make them into an object, and move them out to S3. Or, for example, if you're a photo environment, like a Netflix or Flickr even, is probably a better example, where groups of photos are contained within an object, you can actually go in and pull a photo out, change the color on the photo, or change the tinting, put it back in the object, seal the object up, and then export the object out for archive or backup or for other photo processing somewhere else. So this is uniquely different and innovative in the industry, and we're the first to bring this to you. And you'll see us talk more about case studies and solutions for unified file object as we go through the balance of this quarter and into the fourth calendar quarter of this year. That's good. And then, of course, from a deployability perspective, we'll see this widely deployed through on-premise virtualized environments and public clouds. We'll see a deep unification now of file and object storage, and it's just, it's clearly not at the management layer. It is truly down deep in the file system, and it's not file or object or file. It's both. It's unified. So when you're storing files, you have the capability to actually access and view them as objects as well, and vice versa. So we see this as completely compatible with Amazon S3. We're using a RESTful interface that supports all of the same commands for creating objects, for putting objects, for getting objects, and certainly deleting objects as well. Okay. And again, still built to run on commodity hardware. So today you have an opportunity to build a RESTful S3-like environment or object storage-like environment within a commodity hardware solution. So let's take a look at a migration approach. So some legacy apps, quite a few, maybe 90% of the legacy apps, built to run in a Unix, Linux kind of environment that are using POSIX standards, storage, networking, and file storage, have had a bit of a problem migrating to the cloud because there has been no NAS or network attached storage, POSIX compliant NFS and SITS access in the cloud. Well, Gluster changed that earlier this year when we announced GlusterFS in an Amazon machine image and brought NAS to the cloud. Now, what we found there is that customers who've had these POSIX compliant legacy applications are now starting to migrate into the cloud because they can move their applications up there and have NAS support, storage, network attached storage support. And that's one step. That's one step in the right direction, but there are other legacy applications that would do very well in moving to the cloud and having NAS and also object store capability as well. So many customers have been using gateway products to batch up NAS files and then export them to S3 from companies like Surface and Nisuni and other gateway kinds of products that sit in the data center and export large groups of files into the cloud. And that's a fine concept, but there again, it's another hardware bolted in kind of concept that creates a lot of work for folks and certainly creates a lot more power and cooling requirements and more appliances to be installed. So our approach is to say, well, let's install this unified file and object and give you the capability to create your own cloud anywhere you like. In this case, this cloud at the top of the diagram is GlusterFS 3.3. And sitting right within your file system is the capability to build your own cloud environment. You too now can have NAS and object storage in your own cloud. And that cloud can be in the data center, or you could choose to install within Amazon or GoGrid, and you have the opportunity to migrate your files into objects and move them to the cloud. So we'll see use cases are now in process and being deployed. You'll see use case and case studies on gluster.com soon over the next few weeks, where in data centers we have customers taking control of their cloud services. Some of them are reducing dependency on AWS S3 costs. Some of them are basically saying, well, we were thinking about going to AWS or cloud.com or Rackspace or somewhere else, but now we're thinking of, hey, possibly we want to build our own cloud and have our own cloud services infrastructure within our enterprise. And customers can do that today with Gluster 3.3. And that's through the unified file and object capability. And infrastructure as a service providers love the concept of having a unified file system and not having to depend on separate storage elements within the cloud that give them duplicate storage infrastructures with 2 or 3 different functionalities. Now they can have a common storage infrastructure and greatly reduce the cost of storage. Another thing that we've done recently is some work with OpenStack. OpenStack is an open alternative cloud computing environment, an alternative to, say, GoGrid or Amazon for entities that want to build their own clouds. Some large enterprise kinds of customers would like to build their own cloud, create their own cloud environment, and then OpenStack was created in an effort to support that kind of environment and to bring adoption of an open and open source kind of approach to cloud computing, and certainly provide the compute layer, as we see on the left-hand side in this OpenStack prior to Gluster illustration, a compute layer, an imaging services capability for document imaging, and then an object storage environment, all underneath of an API layer that ports mobile applications, web clients, and enterprise software environments, and a large ecosystem to support cloud computing from an open source perspective. Now, if you look at that diagram on the left, you see compute and you see Swift object storage, and that's great, wonderful elements of cloud computing. But again, what you don't see is file serving in the cloud. Very basic core component of computing today is file services or file servers. And so that was missing. And so if you look on the right side, and as of July 27th, we see the same OpenStack kind of layered cloud compute environment with GlusterFS now as the NAS file system in the cloud, and also the object storage file system alternative to Swift. Now, this is not a direct replacement for Swift because today there are 300,000 deployments of OpenStack globally in many large enterprise environments where people are betting their business on their own internal enterprise cloud, or a private cloud, if you will. This is a good example of a private cloud. And now they have a choice. If they want to migrate their applications to the cloud, their own private cloud, they can use GlusterFS 3.3 for that migration capability, as we just talked about. So, certainly not an easy subject to cover in a webinar and get crystally clear, but certainly it's a good start for you to understand where Gluster is and GlusterFS is today. So the OpenStack with Gluster today now supports an API layer into the cloud for all of the applications we talked about, mobile apps, web clients, and enterprise software, a compute layer, a NAS layer, an object storage layer, and an imaging services component as well. So a much more well-rounded birthday as a official community and operation. So we were part of that. We attended their birthday party in Portland this week at OSCON, or the Open Source Conference, and we certainly supported it and enjoyed having a nice piece of their birthday cake with them while we were there. Also, what we introduced with respect to OpenStack is bringing the ability to move virtual machines from one physical compute server to another physical compute server within OpenStack. Now, there have been other attempts to do this by a couple of other open source companies to move virtual machines between physical servers. However, it's not quite the same as what GlusterFS does. So if some of you on the call today understand VMware, you'll understand that where you see GlusterFS layered in these diagrams is exactly where VMFS layers within the VMware environment. So if we use that as an analogy, we know that the storage controlled by the file system is the common element that once enabled and has the intelligence to support the movement of virtual machines can do that. So what we bring now to OpenStack is a much higher level, more highly performant kind of shared storage environment where you can now very easily move virtual machines from one physical server to another. So that would be a hypervisor environment like Citrix Zen or Red Hat KVM. And being able to do this is important. And it's not just for high availability of applications, although that's a component of it. It's also for better performance management of the cloud environment. And, this is how clouds are able to successfully utilize massive amounts of hardware and give you virtualized computing environments. And so today now we make OpenStack even more robust with the support of virtual machine movement and effective virtual server performance monitoring and management as well by moving virtual machines to physical servers in a virtual motion kind of environment for better resource management and control within that environment. So some customers love Gluster, and they've deployed and bet their business on it. One of them is Pandora. Pandora has built their own private cloud using GlusterFS on commodity hardware, and in fact, Pandora told us recently that they would not be able to do what they do without GlusterFS. So if you listen to Pandora Internet Radio, what you hear in your ears is information that's been stored through GlusterFS on commodity hardware and then brought back up to be pumped out to the Internet and for your listening pleasure. Brightcove is another example of a private cloud with GlusterFS where Gluster is deployed on a double-digit petabyte kind of media repository environment where videos, essentially videos, are stored within Gluster and then delivered to the user upon their selection very quickly. And in fact, Brightcove says that they actually do most of the media serving from Brightcove when you select a thumbnail and then play a video on the internet. Most of those videos come up from Brightcove, from that Gluster repository where the videos are stored. So another amazing use case for Gluster in that most of the world's videos that are played are actually coming up from a Gluster file system environment. Cincinnati Bell is another example of Gluster here in a virtual machine environment. We're installed in a VMware environment within a virtual machine as a container above the hypervisor and above VMFS. Cincinnati Bell has chosen to use GlusterFS as the file system of choice moreover than VMFS. So there is still some layering of VMFS because it's inherent and an integral part of VMware. But they certainly use GlusterFS for all of the live real-time data characteristics of the telephone company and their hosting environment today. Partners Healthcare is another environment where we have a large repository of both medical images, diagnostic result characterizations from a an image source kind of environment, and then also a financial services repository within the Gluster file system as well. So healthcare certainly is a good consumer of the GlusterFS technology and that innovative no metadata approach where being able to read files and access them very quickly is certainly a real-time requirement within the healthcare industry. So today we have 4 supported ways to consume GlusterFS, and that's through virtual machines. You can deploy on VMware, Xen, and KVM, and you can purchase this element or this instantiation of Gluster from our website. We have a store where you can just click through very quickly to get to and purchase these instantiations from the store. Also, Amazon Web Services is another way to purchase Gluster, and that's directly from Gluster as well, purchasing the Gluster Amazon Machine Image, or AMI, directly from us and then deployed through Amazon Web Services. RightScale is a third element where you can purchase Gluster through RightScale directly, and they will deploy it through their cloud management software, dashboard software, and it will be automatically deployed within Amazon Web Services and EC2 instances via the RightScale management dashboard. Also, what's not on this slide is the GoGrid implementation, or the GSI, Gluster server image for GoGrid, and that is directly deployable and purchasable at gogrid.com. So you can now deploy GlusterFS Cloud NAS within a GoGrid environment. And GoGrid, if you're not familiar with GoGrid, they are targeted for the high-end enterprise environment who needs to deploy cloud applications and cloud storage and support users for cloud on a 24/7, 365 basis, not a consumer-oriented kind of web services environment, but more of a high-end, high-availability business-type solution for cloud. Also, we have the storage software appliance that is designed to be installed on bare metal. For example, 2 Dell servers, or maybe 4 Dell servers, or 25, 26, 28 Dell servers with storage attached to create a very large clustered NAS environment right on bare metal, and can be installed in the data center or private cloud as a turnkey solution to deploy a high-performance network-attached storage file server environment that provides lightning speed file access and delivery to application environments. So some of the company we're keeping today includes A&E, Humedica, Beijing Film Academy, Deutsche Bank, Noble Energy in the Middle East, Barnes & Noble, Envoy Media, Samsung. Large companies, large enterprise companies, global conglomerates are finding that Gluster and GlusterFS is dependable and deployable and easily maintainable from an enterprise perspective, and does deliver the kind of performance and availability they need from an enterprise file server and object storage environment. So, looking at what we've covered here today so far, we have the characteristics of GlusterFS, a scale-out file system that supports NAS and object storage in a unified file and object environment. We have extreme flexibility and scalability, linear scalability of capacity and performance, and superior economics. When you think about deploying this kind of technology on commodity hardware, it's just an incredible value proposition for the IT environment. And we support OpenStack, that open cloud computing initiative with unified file and object, and now also bringing virtual machine, virtual motion to that environment in a seamless and unified common virtual storage pool approach. And then we believe, pretty clearly, that our innovative architecture provides truly a better way to do storage, and not just a new and innovative way, but really a better way when you have software, storage as software, deployable within a data center on bare metal, in a virtual machine environment in a data center or private cloud, and also deployable within the public cloud in a few different instantiation models today. We believe, and many of our customers believe, that it truly is a better way to do storage.
All right, thanks, Tom. I think that concludes the end of our presentation. At this time, I'd like to go ahead and give you guys a reminder that we do have some time left in the hour for questions. You're able to, type in your questions into the questions panel using the GoToWebinar platform. So there's already a couple that have come in that we will address, but feel free to add your question at any time. So I guess, let's see here. The first one that I noticed is, which relates to the point where you were referring to ISON, and you talked about the scalability limitations. And somebody had asked, are there any scalability limitations for GlusterFS?
Well, interestingly enough, we do have a limitation on the granular side. We limit the number of nodes installed to, we don't limit it, we start it at 2. And we typically will not support one node and storage with the file system, and that's because we want to assure high availability. And so having 2 nodes or 2 file server controllers helps to assure a higher level of availability to files and data. From a scaling perspective and scale-out perspective, there is no practical limitation to the number of nodes that can scale out and scale up within a concurrent instantiation of the file system. So we do have customers that have run 64 and 128 nodes, and even larger number of nodes when we look at the complete global namespace characteristics of how we're deployed today in the cloud and in the data center. We have large numbers, high quantities of nodes that are running quite well. So we have no real practical limitations since there is no metadata server, and we're using hashtags. There's really no practical limitation to the number of nodes or capacity. Now, having said that, there is something called common sense and know-how that comes into play, and so that's where our systems engineers and professional services folks work with all of our customers to make sure that we don't go hog wild and crazy with some huge number of nodes and capacity that aren't quite configured correctly for the actual requirement. So.
Okay, and as a follow-up question to that, what about file size? From a performance perspective, is there any limitations on file size, large files, small file types?
Well, so ideally with GlusterFS, the best file size is our large file size, large and largest file size as possible, but that's not necessarily different for other file systems either, because given the nature, especially if it's TCP/IP, NFS or CIFS, there's a lot of protocol stack to go through just to store a file or then to go back and open a file. There are a lot of things that have to happen from the protocol perspective. So if you're storing lots of small files and you're operating or executing on those small files frequently, you have to go through a lot of protocol just to do that. So the perception and the appearance of performance not being great is pretty much common for every file system in that environment where you have lots of small, teeny little files that are being operated on frequently. That's kind of inherent into the network design today. But if you have larger files that are stored and operated on at a frequent rate, you tend to have a perception of better performance. So the difference with Gluster is that the time to find the file and open the file and then read the file and operate on it is exceptionally fast because we don't use the metadata server concept. So even though there is a lot of protocol overhead, right, we have exceptionally fast performance on small files and large files. And the example there is within Amazon Web Services. They've been very network bound, very, very large amount of protocol to go through just to use elastic block storage with instances of servers. And so layering in Gluster there and creating a NAS file server in the cloud has increased performance exponentially because we aggregate and virtualize the elastic block storage on the back end. And we also have the benefit of no metadata servers. So not only are we getting the parallel performance characteristics of large amounts of storage transferring data in parallel, we're also getting the benefit of the fast read and access and movement of information because we don't have a metadata server. So that's how we're able to deliver NAS in the cloud and have customers actually move from the data center to the cloud and still meet their SLAs just as they did in the data center, right? That's been a problem in the cloud because of network performance. Nobody wants to run time-sensitive applications over the internet, but now you can, right? The traditional model is to keep data very close to the applications so you don't have time-sensitive delays. Well, that's been a problem, and moving to the cloud today, it's not a problem because customers can move their applications to the cloud, have their data in the cloud, the POSIX-compliant applications to the cloud, have their data in the cloud near the application, or if they don't have the application in the cloud yet, they can move the data to the cloud with the GlusterFS NAS environment in the cloud and not worry about the performance bottlenecks that were there. They're gone. Gluster got rid of them.
Right. Kind of a feature type question. Does Gluster support snapshots?
So from a cloud perspective, Gluster supports, for example, in an Amazon Web Services environment, Gluster supports the snapshot of the Gluster file system and elements within it, or parts of it within it, right, volumes, into S3. So that snapshotting capability is there. From a comparison to, say, NetApp snapshots and SnapMirror and all that kind of thing, that's coming. That's on the roadmap. That will be part of the Gluster file system. GlusterFS was not designed for snapshot kind of environments. We all know, maybe we know what snapshots are for, but they're for ongoing and potentially rollback recovery or even backup and archive of specific parts of file systems or all of the volumes in a file system. So that's coming. We'll support that. We were designed for performance and a need for speed. So if you take Pandora as an example, they're not necessarily worried about snapshots. They're worried about moving information, the latest Lady Gaga song, out to the user very quickly, not necessarily snapshotting the song and backing it up. They don't need to do that. They can restore the song very quickly, even off of the CD, right? So that's where we were initially designed. Those were our design points. But commercially oriented customers who use snapshots for all kinds of different reasons have essentially said, Gluster, we'd like you to do that too, and we will do that.
Great. Let's see here. The next question I have is around encryption. What type of encryption is used on the connectivity between the nodes? If you can address me with that.
Okay, so today there are a couple of ways to actually work with encryption. We have partners that we work with to do encryption functions within the file system or encrypting information that comes out of the file system and sending it off to other elements within the enterprise. That's very common right now in the government area that we work in, federal government and other government areas outside of the U.S. that we work in. Encryption within the file system is a roadmap item that's coming soon. I can tell you that it's coming soon. We're also looking at a number of other things along those lines, a number of other functions or functionalities from a encryption perspective that will be very attractive to certain IT environments this year, or coming this year. But the inherent basic element of encryption within the file system is something that we've been working with partners on to date.
Great. So I know we're nearing the top of the hour here. Just kind of want to remind everyone that we will be sending out a link to the presentation slides as well as a link to the recorded version of this webinar. If you do have any additional questions that come to mind, please send them in to info@gluster.com. Just as a reminder, we do have free trials available. Say this does sound interesting to you and you want to get a free trial going, just go ahead and visit our website, gluster.com/try-by. We have free 30-day trials available there, or just go to gluster.org and you can download the free open source version and see if it makes sense for your environment. Once again, thanks, Tom, for all this great information. Hopefully this was useful for all of you that attended. And again, thank you.